big picture here is we want to get the sum of squares residuals, and that gives us an index of the error in our model, so the extent to which we're not predicting as well as we'd like. And so we're going to get to the sum of squares regression in a second, but we're going to tackle the error first. Okay, so remember, residual is the amount of error. So what you can do is go into the data set and save the residuals from the regression, like in the previous slide. So you can save those on standardized residuals, and then what you can do is square them all by using the compute function. So go to a transform compute, and then take that unstandardized residuals and pop it over into the box, and then type 2 stars and then the number 2, and that raises it to the power of 2. So remember, in Excel it's a caret 2, and in SPSS it's 2 stars and then a 2 to raise to the power. So it's just different ways, I guess, this different software does things. So anyway, there's some notes in the bottom of this slide that you can take a look at in order to do that, and then run the descriptive stats and get the sum of the squared residuals, and you will find this output. It should match this output in the slide here. The sum is 6.54, and it will be the same as the sum of squares residual in the ANOVA table that we got in the output that we did in the previous analysis, where we regressed GPA on the GRE quant. And so it's really kind of cool. I mean, within rounding error, of course, there's a little bit of discrepancy in these two numbers, but you can calculate the sum of squares residual and kind of demystify that whole process. So what we get in the ANOVA table is just simply taking all the unstandardized residuals, squaring them, and then adding them together.